Okay, I'm Andrew Urquhart. I've seen a lot of Who Am I slides, and I didn't think about including one. I will point out I do have a PhD, but it's not in computer science. I've seen a lot of computer science references. Sorry, I'm actually kind of a crazy physicist here. When the time came to get a job, luckily I also had a knack for programming. I had it as a hobby, and it turned out to be far more profitable. I'm with Raytheon, and I'm here today to discuss searching with polygons. I budgeted my charts to have some time for questions, and gave myself a fair amount of time per chart, so the slide deck may be a little bit short. I apologize if we go short. On the other hand, it's the end of the conference, so you may appreciate that. Hey, start off, I'd like to talk about what my motivation was for this. And the term we like to use is burning platform, and to me, I'm out of Texas, so burning platform always makes me think of an oil drilling platform on fire, and you're standing on the platform, and you're really motivated to take care of the problem. So what's our burning platform? We have a current application that is dependent on a well-known proprietary database that has really expensive licenses, and it turns out it's being used basically for search. So as our customer space is looking at major cost cuts, they have a big motive. One, they would like to be able to deploy more instances of the application, and two, they're looking at some major budget reductions, so they really need to get their costs down. And this proprietary database is a major cost driver that's unsustainable in that budgetary environment. So Solr is identified as a promising replacement candidate. The cost is excellent in that it's free. So like that, it has excellent performance, and if there's something really wrong with the source code, we can get in and we can get into the source code and fix it. Major weakness with it is that our application absolutely requires geospatial search with polygons. I've been hearing that there are some other people who have that need, we understood that, and I believe that's why this talk was probably selected. So the next question was, could we mitigate this? And the answer has come out yes. Our requirements: we have to index index points for search by polygons, and we should also be able to index polygons to search by polygons. That case has not really come up as a use case in testing, but we do have implementation against it, expecting that it will come. So what we have, I have it on my workstation back down in Texas. This is a runnable system. It's more of a matter of being able to get it to you that's the issue, rather than does it run. And I think we want to do some more testing on it. Right now it's a single add-in jar plus some schema and other configuration changes. There was at one point, some people who have seen these charts or saw the abstract or some of the discussions we've had, there was a GPL dependency at one point. That is completely flushed. It now has no GPL dependency. So we're hoping we'll be able to contribute this as soon as we can work the politics on that. The internals, we looked at the Lucene Spatial Playground, and I didn't like some of the things that I saw there. One, I didn't like the JTS library because it has two-dimensional mathematics, and it seemed to have a vulnerability to special points such as the north and south poles, the 180-degree east-west meridian, where you get some mathematical issues going on. So I wanted to get around that. And in our customer space, that could be an issue. And I heard somebody else saying that I heard a rumor that somebody else has been having that issue with looking at oil drilling up in the Arctic, where you're kind of right around the North Pole. So there's another application. I also didn't like that it had, I thought it had an LGPL license library on the JTS, which at one point I ended up with GPL, which was worse, but now I've been able to get away from that both. For ability to deploy this within a commercial environment where you've made code modifications, it's best to have no Apache license is far better. Plus, for being able to contribute back to Apache license is far better. JTS does have one advantage over what I have implemented right now, in that JTS does support complex polygons. Those polygons with holes are actually where you have disjoint sets of polygons, like you might consider the Japanese or Hawaiian Islands as examples where you may care about disjoint polygons. Don't have that yet. I actually may be working on that in the near future, and I don't think that's going to be a big issue from where I am now. So what is the magic behind how this works? Now, there are a couple of pieces of the magic. The first one is I started off with geohash coding. I like the geohash algorithm, but I didn't like that it put things out in strings, and I didn't like that it did subdivisions of 32. So, trying to address that problem, basically I wanted to be able to do a tree, the Trie data structure, to be able to do the search on the hash. So I wanted to get over to a long integer. So I've got a long integer encoding, and the other thing is I've got it where you have to divide by 4, and then there's a bit that flags if you want to stop there. So it has kind of variable resolution in it. You can read the details up there, and I think I messed up on the precision calculation. I redid it this morning, and I think it's more 10 meters. I did about a factor of 100 slip. Sorry, that started during my qualifying exams right in the middle. But it's about 10 meters, so one tile square would fit in this room with this encoding. So it's pretty precise. And points are indexed by the smallest tile that contains the points. There is a problem with this. I'll see if forget if it's coming up. I'll mention it here. What about polygons? Basically, I generate all the tiles that are in the polygon and index those. And that can be quite a large number. It depends on the shape of the polygon, how big it is, and how the boundaries run. Complex boundaries are obviously going to give you more tiles, and also just very large polygons. Unless you happen to hit right on a geohash boundary, they're going to tend to give you a lot of tiles, a lot of hash values. Oh, the issue that happens is when you go to do a query, because I have to index, if I have a polygon, I have to index the polygon with all these tiles. And when it comes query time, I have to then query all the tiles. So if I wanted to query Boston, I'd have to query all the tiles for Boston, which would probably be larger. There's I don't know if you're aware of it, there's a limit to the number of Boolean clauses that is configured normally in Solr that's about 1,000. Maybe 1024, but it's about 1,000. So to deal with that, what I did is I backed off the resolution. Basically, I generate the tiles. If there are too many of them, then I back it off until I have about 500. And that could probably be tweaked. Basically, I do that as I'm building the query. It's definitely designed at Solr. There are pieces that you could use from Lucene. So basically, I did a custom query parser, and then that builds a Lucene query that then it puts in. And there are some custom query classes, then it gets down to a numeric range query, which came to some of the magic because one of the points that's actually up on the slide is the smallest the smallest tiles, these 10 meter by 10 meter tiles, your boundary may cross, and the assumption is you care about it, especially if you've had to back off your resolution some to get the number of index tiles down for the Boolean clauses. So as a result, there's actually, within the query, I insert a filter that goes ahead and actually checks the polygon boundary. So once it's retrieved the document, I have to know what the original geometric specification was, reassemble that, and then check that against the actual boundary. So the the index retrieval is actually kind of a first stage rough retrieval, and then there's a there's a filter that refines that. I've recently also implemented it as a filter query that will just do that second filter. Some other stuff I'm needing to do that's outside the scope of this talk, I had to do filter queries, so I needed it all symmetric. I've already hit some of this. Actually, I think I've already hit a fair amount of this. Maybe all of it. One thing I mentioned is before I back off the resolution, I did try and look and see if I can consolidate adjacent tiles into ranges. And right now I'm just doing Z order. There are some other, I think there's some Hilbert curve orders, but I was concerned about some possible conflicts that might mess up licensing, and I thought Z order was safer to stay with for the community. Hilbert you could implement a curve that might be slightly more efficient on the tile generation. So how do we actually use this capability? It requires the use of some custom field types in the schema. Right now in the committer, this might be something as the contribution process goes forward, exactly how this works might need to be adjusted. I've got, well, the schema has some specific types for each supported geometry type and then a general type. I'm deliberately using a specialized geometry encoding because I don't want it to get confused with well-known text, because I don't want people to think that everything in well-known text is supported. And right now, the number of, there's pretty much only one crazy person who knows how all this works. So some of these decisions might get revisited in the future as it gets released out, and hopefully released out into the community. Response to a question earlier, I believe I already addressed that the search is accessed through a custom QParser plugin that then goes through the parsing. And I'm not sure if this is the right way to do it, but what I've done is basically I've added, or I detect a suffix, a special suffix on the end of the field name that tells me what type of geometry specification I'm looking at. Strip that off before it goes to the index, but that allows me to then process in the geometry. Is that a good thing to do? I don't know, but right now it's working. And then it goes ahead, I think I already covered this, it does the index tiles and builds the Lucene query structure. What type of geometries do I support? I support points specified by latitude and longitude. Polygons that are specified by latitude and longitude pairs. I said simple polygons right now. Lat-long boxes, which are converted internally into a polygon. That's kind of a simple one to do. And point radii, which are actually then converted internally into a polygon approximating a circle. And exactly how much you approximate will affect performance. Right now I think I'm doing a 16-sided polygon, evenly spaced in degrees around. As far as contributing this back, have to work through some bureaucracy issues, working through the company. The thing is, it was done under a customer contract where the customer has unlimited rights, and the customer is this particular customer is also allergic to anything being called proprietary. So they actually are very likely to, or we're hoping and have some reason to believe that they will direct us to contribute it to open source. Because basically they have to be able to pick it up and give it to our competitors if they want to do so. But that also means that y'all should get a hold of it. And I know there was something that was, something I just realized completely missing from the slide deck is I didn't talk at all about the internals on how mathematics is done. I think I just glossed by it. What I do to avoid some of the North Pole issues, some of the issues with the 180 east-west meridian is I get it out of lat-long space and I put it into three-dimensional space. Now, I don't handle any altitude, but I put it onto a perfect sphere. There is something called an ellipsoid, a standard ellipsoid. Don't know if any of y'all care about that. And it could come into effect with distances. If you were doing, with that point radius search, it could affect things a little bit. But when I go into three-dimensional space, at that point, the North Pole is just like any other point, so it's not a problem. And all then my internal mathematics, like the intersection, do two lines intersect, is a linear algebra problem. So at that point, the linear algebra got interesting. Turns out it's only three-dimensional, so it's 3x3 matrices. Inverting that, you can do. I can do it on my whiteboard and then just code it up, so it doesn't have to do any iterative processing. But that's some of the magic that allows it to. And that's in the magic that allows it to work, and it also avoids all the complications of spherical trigonometry. Basically does sines and cosines, and that's it. So we found that Solr is an excellent choice for if our need to replace the expensive proprietary database. And we could get the geospatial search implemented. It works pretty well. Very happy with it. It can be used with or without the Lucene Spatial Playground. There are some things that the Lucene Spatial Playground code will give you that this does not give you, such as if you want to sort by distance from a point. This doesn't do that. The Lucene Spatial Playground will do that. So there may be cases where you would actually want to do both. And I apologize. I realize I keep talking to the side of the room and ignoring that side of the room. I apologize for that. I think it's the podium being over here. It does. I just mentioned the three-dimensional mathematics. I do have to store the original geometry specification so I can recall it to filter the search results, and uses capabilities with new field types, and new QParser plugin are required to implement this. And I think I just hit that. It's not yet released to the public. Trying to work through those issues to make that happen. So I'm probably way ahead on time. So it's what's the difference from the geofilt? For just the radius filter, it's basically I'm to the point where I'm already doing everything with polygons. So I kept following that pattern. Oh, and I forgot to repeat the question, didn't I? The question was, why am I not using the geofilt for the radius filter? The geofilt capability that's already in Solr that is already in the system. And it's basically I got to the point where I was so emphasizing polygons, I just kept the pattern going. So that may be something that could be future work that may need to be from a contribution before it would become mainline code. Okay, I may have been unclear on it. The question was, I'm indexing field data to different fields based on the extension of the name of the field. I may have unclearly spoken. I'm using that at query time. So when the query comes in, trying to figure out what is this geometry that's been specified. So, and part of the problem is I need to be able to search for a point using a polygon. So it's kind of, I'm searching, it may have been indexed as a point. In fact, I'm expecting it's been indexed as a point, and I need to search as a polygon. Or I may have something that came in as a lat long box, and I need to search for it with polygon, or vice versa. I may have had a polygon come in and need to search for it with a lat long box. And so it's trying to get a relatively simple interface to pass in the specification. Like a lat long box, I only need to specify 4 numbers. The latitude and longitude of one corner and latitude and longitude of the other corner. I don't, why should I, in the interface, why would I want to specify all the points when it's very redundant information? Yeah, the question is could I be using the local parameters? Possibly. My experience, the thing is, my experience with Solr goes back to about January. So I'm actually fairly green. There may be a lot of things that I missed. A lot of it was much more getting the mathematics working and seeing if this could work. There may be a lot of refinement that's needed. On the other hand, it's a working system. The question is, how extensible is the code to do high-dimensional search? It's really aimed at geospatial search and at three-dimensional search. From what I've seen of the code, my first thought with higher dimensional search, if it's in a kind of a Cartesian space, I would tend to actually aim for the Lucene Spatial Playground. I think that may already have what you want. Now, if you needed to do some sort of, worrying about searching on a surface in high dimensional space, that's going to require some creativity. Question was, why did I come up with this rather than going with the Solr Polygon Support, or the Lucene Spatial Playground and its Polygon Support? Part of it was that the Spatial Playground, when I looked at it, looked like it needed a LGPL license, which is more than the Apache license. And also, a bigger driver to me was that fundamentally the Lucene Spatial Playground really likes to work in a Cartesian space. So it basically tries to map the Earth flat. If you're dealing with a city, you can do that in most areas. Maybe even with a state, you can probably do that in most areas. If you're dealing with oil drilling in the North Pole, it's going to really, or in the Arctic near the North Pole, it's going to really hurt you because of the distortions. If you look at Greenland projected on a map, just on a 2D map, Greenland shows up with an area much larger than is really the area of Greenland because you've got so much distortion as you go to high latitudes. Even as you're getting up to the latitude of Boston, you're picking up some of that distortion already. But it gets much more severe as you go north. So if you want to have a global solution, despite the fact that the JTS library was, I believe, was written for Canada, I think it was for one of the Canadian provinces, maybe British Columbia, although I could be completely wrong on that. I'm pretty sure it was written for some entity under part of Canada. And Canada goes fairly far north, but still it does a flat projection. I think that was considered good enough for their needs. Now the question was, with really big polygons, do I have problems disambiguating the northern hemisphere and the southern hemisphere? Right, if somebody wants the larger set rather than the smaller set. Right now, I probably actually would have a problem with that, because what I'm doing with the non-GPL code, or the code that doesn't involve the GPL dependence, determining if a point is inside a polygon on a sphere was one of the hard points, and that's where I had a GPL dependency. There was a library from the National Snow and Ice Data Center that had that capability, but there were polygons it could not handle. They were unlikely to occur, but it could not handle them at all. So what I did is I did some math, and once again, some linear algebra involving several cross products that basically says, does this polygon go all the way around my point? Or does it go, if I kind of watch that polygon kind of going around the ball and just literally adding up the angles subtended by the polygon edges, does that come out to be 0, or does that come out to be something that's that's 360? With the approach I'm doing and talking through it, I would probably say that I was on inside in either case. So that may be an issue to consider. I actually I thought of it in the past, but then I'd forgotten it. So thank you for bringing it up. I need to think about that one. I may have to worry about, is it plus 100 or 360 or minus 360, which I'm currently not doing. Well, thanks for the questions, and thanks for staying this late in the conference, and I appreciate it.